When you enter the chemistry lab for your chemistry practical in the WAEC exam, what exactly are you expected to do? When you carry out your practical, you are expected to get your average title value from that practical. Now listen to this. You don't need to master or to cram a particular average title value online. Each school, you're going to have to carry out your practical in your school, and there's a report that your chemistry teacher is going to write. Okay, so the WAEC has sent a form to every school, and then your chemistry teacher is expected to fill that form based on the experiment that he carried out using the materials that WAEC had sent ahead of time. So based on his report, he's going to write his average title value in that report. And that is what WAEC is going to use to judge your calculations. So you don't have to be specific about my average title value or any other one you find out there. What is important is getting your calculations correctly. And that is why now, based on the average title value in your center, you could be given a range of figures. All right, you could be given a range. So once you have that range of figures, meaning when you carry out your practical, this is supposed to be the range of where your average title value will be. So I'm going to show you in this video how to plot the table. Once you have that range, you really do not need to waste time doing the practical again and again. Once you do it once and you get a value that aligns with the range, you can go straight, plot your table, and start solving the question. So today, I'm going to show you how to get that table done in a very simple way. You plot your table. Are you with me? Getting your average title value, you plot the table, and then the calculation will follow. So I'm going to plot the table for you, and then we'll do the calculations as well. How can I construct my table of results, my result table for the titration, and to get my average title value? Now remember, I told you the average title value of each school differs. That of your school differs from that of other school. So in your school, based on the experiment you carry out, there is going to be a range of figures. Your teacher could actually reveal that range to you. Okay, so within that range, your whatever calculations, whatever experiment you carried out, your average title value should be within that range. Now, once you have done that experiment once and you see that the value you got is within that range, you don't need to waste time trying to do it the second, the third time. You can, from one value you have, you can plot the table. So I'm going to show you how to plot the table right now. Now, the first thing you do, I've given you an acronym, B5. What is the meaning of B5? B, F, I, V. B5. So those are the things that will be on this vertical. So your B simply means burette reading. Burette reading. Then this is final. You can write final reading. This is initial reading. Then this is volume of acid used. So you draw the table. Mind you, this burette reading has to be the SI unit for this reading is centimeter cube. So you can either write your centimeter cube here, it covers for everyone, or you repeat it centimeter cube, centimeter cube, centimeter cube. Ensure to have that SI unit, all right, so that you will not be penalized. Now, after that, you can now divide these. You can have rough, you can have first, then you can have second reading, and then you can have third. You are expected to have a minimum of 3, maximum of 4. What do I mean by 4? The rough 1, 2, 3, 4. So these are 4 trials you did. So you can have rough and just 1 and 2. That is 3, but then you can also have 4. I'm going to be making use of 23.20 as my average titer value. So my average titer value, which is the same thing as average volume of acid used, is 23.20. 23.20 centimeter cube. So what I will do, how do I get this? So the first thing, initial. This initial, you can just put 0.00 across board. 0.00. Mind you, always put your readings in 2 decimal places. That means after this decimal, 1 to 2 places after the decimal. Average volume of acid, this is the value I'm trying to look for. All right. So I'm going to try to have my figures. I can add a little to this and remove. I can add 0.05, okay, plus or minus 0.5. 0.5. So like I said, B5, BFIV, that's an acronym, B5, BFIV. B means burette reading, F is the final reading, I is the initial reading, volume is volume of acid used. So I'm about to use 23.20. So let's assume you were told that your average titer value, the range is somewhere around 23.20. So to plot this table in a very simple way, what I can just do, or what you can do, you can decide to add 0.05 and remove 0.05 from this value so that you can get this. All right. So here I can write, since I have 23.20, I can add 23.25, 23.15, 23.20. Now, if I remove 5 from 23.25, I remove 0.05. I'm going to have 23.20. That 5, I had it here, gives me 23.20, and now 23.20 here. So whatever is, so now my rough, I can also have maybe 23.25. Okay? So the implication of that, I'm coming back to that. Now, your final reading, the sum of your initial and volume of acid used, the sum of these last two must be equal to what you have here. So if you add this to this, it's going to give you 23.25. Add this to this, 23.25. Add this to this, 23.15. Add this to this, 23.20. So once you have done that, your table is set. So now, my average titer value, I'm now going to do this. I will pick 3 from here. This last 3, I will add it and divide by 3. So if I'm going to do that, I'll have 23.25 plus 23.15 plus 23.20 all divided by 3. So if you add all of this together, it's simply 23.20 in 3 places. That would be 69.60 divided by 3. And that will give me my average titer value. Okay, average volume of acid use, which is the same thing as average titer value, and that's going to be 23.20 cm cube. Ensure that you put your SI unit. You have your average titer value. Ensure that the SI unit is correct, centimeter cube. Then you can go with this back to the questions and answer the questions. All right. So once you enter the exam, you don't need to waste time. Just try out the practical ones. See if your answer aligns with the range that your teacher could actually whisper to you. All right, to just let you have an idea of the range, and then so that you know that you are on the right track when you do your first exam. So once you do the first one, you can just compute your table and go straight to answer the question. All right. If you have any question, please drop it in the comment section. And if you have not subscribed to this channel, please subscribe right now. Share this video with your friends. And do not forget to like it as well. Now, after getting your average titer value, now let's go and solve the question. The question says A is 0.125 mole per dm cube H2SO4. That means your acid, your A, is H2SO4. All right. Now, this value represents the molar concentration of that acid. So the molar concentration of A is 0.125 mole per dm cube. That is the molar concentration of your acid. B is a solution containing X gram per dm cube of sodium hydroxide. So our B is sodium hydroxide. But this value, gram per dm cube, talks about the mass concentration. Wherever you see grams, mass. Wherever you see mole, molar concentration, mass concentration. Listen to me. You must be able to spell out your parameters correctly if you are going to get the correct mark. Now, for every parameter that you spell out correctly, there is a mark that accrues to that. All right. So this is the mass concentration of your base, which is unknown. So mass concentration of B, X gram per dm cube. So we are going to have to find that as we continue. Now, calculate before you can do this calculation, the next thing you want to do is to write out a balanced equation of the acid and the base. All right, when you write a balanced equation, so there are some questions they might give you. You cannot tell. So in this your exam, they might give you a balanced equation. They might not give you. That might be the first question. Write out a balanced equation. So if you were given, then all you need to do is to inspect the equation and be sure it is balanced before you consider. If you were not given, then you are expected to write a balanced equation. So the last video I did, some people were asking me, how did I get the Na and the Nb? That's the number of mole of acid, the number of mole of base. I'm going to show you that right now from this balanced equation. Now, so the question is, we are dealing with H2SO4, tetrasulfate 6 acid with sodium hydroxide. So this is the acid, this is the base. What is going to be the product? Now, anytime an acid reacts with a base, salt and water must be formed. And that reaction is called neutralization reaction. They can even ask you what is the name of the reaction that took place. When an acid reacts with a base, it's neutralization reaction. So this neutralization reaction. Right. Now in this reaction, anytime an acid reacts with a base, salt and water will be formed. So this acid, when it's about to react, it will ionize. Ionize means it will split into ions. SO42 minus, H plus, SO42 minus. The first thing you do is to ionize this acid. When you ionize this acid, you split into H plus, SO42 minus. The base will split into Na plus OH minus. So like poles repel, unlike pole attract. So the positive and this negative, this positive and the negative, they will come together and form the salt. And when they come together, they will exchange their oxidation number. So this sodium will carry the oxidation number 2, all right? While this SO4 will carry +1. So if you are going to write it, it will be Na2SO4. Take note of this Na2SO4, not NaSO4. If you write NaSO4, the equation is already wrong, and you know the implication of that. All your calculations will be wrong because it's going to affect your calculation. That is why you have to be very careful with this balanced equation. All right. Then plus, when hydrogen reacts with this, you have water. Now, so this is the first stage. You have written out the product. The next thing is to now inspect and balance the equation. So how many sodium do I have on this side? 2. I'm going to have to write 2 here. Then my sodium becomes 2 here and 2 here. How many sulfur do I have here? 1. Sulfur here is 1. How many oxygen do I have on this side? So balancing equation means the number of each element on the reactant side has to be the same on the product side. So here, the number of oxygen here, 4 plus 2, that is 6. Here I have 4 plus 1, 5 is not balanced. So I'm going to have to put 2 here. Now I have oxygen 4, 2, that is 6. Here, 4, 2, that is 6. And then if you inspect for hydrogen, hydrogen here is 2, hydrogen is 2, that is 4 on the reactant side. 2 times 2, 4 on the product side. So here is a balanced equation. Now from here, you will, now for those that ask the question, how did I get my Na and my Nb? Na is the number of mole of acid. So here, how many moles of H2SO4 do I have here? This is 1. So that means my Na will be 1. How many moles of base do I have here? 2 moles of sodium hydroxide. So that means my Nb will be equal to 2. My Na is 1, Nb is 2. So that was that. So once your equation is correctly balanced, that is how you get your Na and your Nb. So once that is done, the next thing is we already have our parameters. So let's rewrite the parameters. Our Ca, which is the molar concentration of acid, is 0.125 mole per dm cube. Then the volume of acid used, which is going to be our average titer value, which I said earlier that is going to be dependent on the practical that you carried out in your school. So don't go and cram one average titer value online and just go and use it. Okay, make use of what you have in your school. So I am going to make use of my own average titer value, and then the average titer value I'll be using is 23.20 based on the experiment. So my volume of acid is 23.20 cm cube. That is my volume of acid used, which is my average titer value. All right. Now, what are the other parameters we have? We have mass concentration of B, okay, and then we have the Na. So our Na from the balanced equation is 1, Nb is 2. The first question that we were asked to solve is amount of H2SO4 in the average volume of acid used. So meaning making use of this, our average volume of acid used, we have to find the number of moles of acid. So the amount of this is number of mole of A is going to be, what formula are we going to use? So the formula we use is number of mole equals to molar concentration times volume. And that volume has to be in dm cube. Number of mole equals molar concentration times volume in dm cube. Note, once you state your formula correctly, there is a mark attached to it. There is something called scoring point in the marking scheme, okay, for your WAEC and for NECO. So one of the scoring points is stating the right formula, there is a mark. Stating your parameters correctly, there is mark attached. Stating your SI units correctly, there is also marks attached. So here, note the volume has to be in dm cube. So we would have to convert this volume to dm cube. All right, so our VA is going to be what? 23.20. We divide it by 1000 to give us our volume in dm cube. So if you divide 0.02320 dm cube, okay, so that is the answer, 0.02320 dm cube. Yeah, so once that is done, now we can calculate the number of moles. We now be molar concentration of acid, which is 0.125 moles multiplied by the volume, which is 0.02320. Or better still, you can just write 23 divided by 1000. But since I've solved it, 2320. All right, so our number of mole, if you punch this in your calculator, 0029 moles in, if you do that from your calculator, so it's going to be 0.0029 moles. That is the number of moles of acid that is present in the average titer value. So we have answered this question, amount of H2SO4 in the average volume of acid used. Now the second question says we should calculate the concentration of B in mole per dm cube. That is the molar concentration. So we are looking for CB now. So now we already have our Ca, all right, we have Va. Our Vb is the volume of the pipette, so we have Vb also, and it's usually 25 cm3. So that is the pipette you use in your school. Some will be using 20 cm3, some 25. Please, whatever your teacher provides, that is what you should use, and that is what he's going to put in the report. So, but most schools, they are going to use 25 cm3 as the volume of their pipette, and that is the Vb. So we have Cb, Vb, then we have the Ca. Our Ca is what? 0.125 mole per dm3. And what is our Va, which is our average titer value? 23.20 cm3. Can you see the two volumes are in cm3, so you don't need to convert to dm3. So here we are going to use, to get our Cb, we are going to use CAVA, that's the formula, over CBVB equals to NA over NB. If you cross multiply, you are going to have CAVANB equals CBVBNA. So since we are looking for CB, we make CB subject of formula. We divide both sides by VBNA. VBNA, VBNA. So if you divide VBNA, so your CB is going to be CAVANB all over VBNA. Now let's impute the value. So our CB will be, what's our CA? CA is 0.125 multiplied by VA, that's the volume of acid, 23.20, times what is our NB? 2, all divided by VB, volume of the base, which is 25, multiplied by NA. Our NA is 1. Remember, we got our NA and NB from the balanced equation. So if you impute these values into your calculator, it's going to give us our concentration of base, which is the molar concentration of base, 0.232 mole per dm3. Now, let me say this at this point. Please, your SI units are very, very important. If you are looking for molar concentration, here they say concentration in mole per dm3, so they've even simplified it for you. So your SI unit has to be mole per dm3. Here, amount, it has to be in moles. So if they say molar concentration, if that's what the question is asking you to do, the SI unit will be mole per dm3. The question is asking for mass concentration, is going to be grams per dm3. So ensure you do not put the wrong SI unit. And then the final question says we should calculate the value of X. You remember the question, we were given X gram per dm3, which is the mass concentration of the base. So now we are going to use the molar concentration of the base to find the mass concentration of the base. Points, if you have not seen my video on stoichiometry, where I actually explained all the formulas and equations you'll be using in this chemistry practical, because you need to know all of them. You cannot actually predict where the question will come from. So it's important that you know all those formulas. Is that okay? So go and check the description to this video. I dropped the link there. Before I continue, if you have not subscribed to our channel, I do not know what you are waiting for. So please right now, hit the subscribe button, subscribe to this channel, and share this video with your friends. Please drop your comment and like this video as well. And once you subscribe, you'll get to see other information, other educational content that we post on this platform for you on physics, chemistry, mathematics, and biology. Thank you very much. Now, let's go to the final question, which is calculate the value of X. Now, we already have the molar concentration of the base. Now, the formula we are going to use to find the mass concentration is molar concentration equals to mass concentration over molar mass. With this formula correctly stated, you get a mark. So molar concentration is equal to mass concentration over molar mass. Now, how do we get all these parameters? We already have the molar concentration. To get the molar mass, you calculate the molar mass of sodium hydroxide. Molar mass of sodium hydroxide. Sodium, you were given 23, oxygen 16, hydrogen 1. So sodium may be 23 plus oxygen. How many oxygen? 1. That is 16 times 1 plus hydrogen is 1. So if you add it, it's going to be 40. That is the molar mass. So for you to get the mass concentration, all you need to do is to cross multiply and it will give you the mass concentration. So we do that right now. The final question says we should find the value of X, and I've told you the formula for calculating. You remember the mass concentration we were given. Mass concentration of B is X gram per dmt. So we are looking for this X, which is the mass concentration of B, and the formula is molar concentration equals mass concentration over molar mass. So if you make mass concentration the subject of formula, the mass concentration is going to be molar concentration times molar mass, and we have calculated all of that. So a mass concentration, molar concentration of B is what? 0.232, all right, multiplied by 40, which is the molar mass of sodium hydroxide. Okay, so when you calculate that, 9.28. Now 9.28, what is the SI unit? Grams per dm cube. That is the answer. So here is the mass concentration of the base, and the value of our X is 9.28 grams per dm cube. Now I hope you understand all that we have discussed. Please, if you still have any question based on this, drop in the comment section and I'll be there to respond to your questions.